Now in this lecture, we generalize to find out the nth root of unity. So similarly, if we are able to find out the nth root of unity, so we are able to find out the any root of one. It may be 3, it may be 4, 5, 6, 7, 8, 9, and so on. So let us try to find out the nth root of unity in this example. So we have to find the nth root of unity. Let x is equal to 1 or nth root of 1, which can be written as 1 whole to the power 1 upon n. Suppose let us give it equation number 1. Then again this 1 can be written as 1 plus I 0 whole to the power 1 by n by finding their modulus and argument, which is 1 and 0 respectively, which implies x is equal to modulus is 1 and argument is 0. So 1 into cos 0 plus I sin 0 whole to the power 1 upon n. Again, we apply the same formula, cos 2k pi plus theta is equal to cos theta. So this can be written as cos 2k pi plus 0 plus I sin 2k pi plus 0 whole to the power 1 upon n. But 2k pi plus 0 is nothing but 2k pi. So we can write down x is equal to cos 2k pi plus I sin 2k pi whole to the power 1 upon n. Now, which gives us, if we apply the De Moivre's theorem, which is cos theta plus I sin theta to the power n, which is given by cos n theta plus I sin n theta. So this 1 upon n is multiplied with 2k pi, so it can be written as cos 2k pi upon n plus I sin 2k pi upon n. Again, we know that e to the power ix is equal to cos x plus I sin x. So we can write down this x is equal to e to the power 2k pi I upon n. Suppose this is equation number 2. Then now if we put the value of k equal to 0, 1, 2, 3 up to n minus 1, then we get the n number of roots, because this is the equation whose power we can write down. This can be written as x to the power n, x to the power n equal to 1, or x to the power n minus 1 equal to 0. So this equation has how many roots? N number of roots. So how to get that n number of roots? By putting the value of k equal to 0, we get the first root. If we put k equal to 1, we get the second root. If we put k equal to 2, we get the third root, and so on. If we put k equal to n minus 1, because it is started from 0, if we put n minus 1, we get the nth root of the 1. So let us try to put k equal to 0. If we put k equal to 0, what will happen? It is e to the power 0, which is equal to 1. If we put k equal to 1, this is 2 pi I upon 3. Let us consider it is omega. If we put k equal to um, 2, so 2 times of 2 pi I upon n. So this can be written as e to the power 2 pi I upon 3 whole square, which is given by omega square. Similarly, if we write down x cube, so it is equal to e to the power 3 multiplied by 2 pi I upon 3, and which can be written as e to the power 2 pi I upon 3 whole cube, means omega cube. Similarly, if we write down x n minus 1, it can be written as e to the power n minus 1 times of 2 pi I upon 3, which can be considered as e to the power 2 pi I upon 3 whole to the power n minus 1. And this is nothing but omega, so omega to the power n minus 1. So in this manner, we are able to find out the nth root of unity. So now this is the very general formula. So nth roots of unity are given by 1 omega omega square omega cube up to omega to the power n minus 1. So in this manner, we are able to get the any root of 1 It may be 3, 4, 5, 6, 7, any root we are able to get it over here. So thank you.